Horizontal projection. When a ball is kicked from the top of a cliff, it moves horizontally at first. After leaving the edge, it continues its horizontal motion with a constant speed, but gravity immediately begins to pull it downward. This downward pull causes the ball to curve away from its original path until it finally hits the ground. The horizontal projection is a type of projectile motion where an object is launched with an initial horizontal velocity from a certain height. This motion of an object can be regarded as a combination of two components. One, horizontal motion, where the object starts with an initial horizontal velocity ux, and ux remain constant throughout the motion. Therefore, there is no horizontal acceleration, which means horizontally, acceleration ax is equal to 0. 2, vertical motion. The vertical component of the motion has 0 initial velocity. This velocity increases by 9.8 meters per second every second. The vertical motion is due to gravity. Note, the horizontal and vertical motion are independent of each other, meaning they don't affect one another. Gravity affects only the vertical motion. Examples of horizontal projection. 1. A ball rolling off the edge of a table. The ball moves forward and falls to the ground following a curve. Water flowing out from a horizontal pipe. The water jets out horizontally and falls downward due to gravity. A bullet fired horizontally from a gun. The bullet moves forward and drops gradually due to gravity. An aeroplane releasing an object. When dropping from a moving plane flying horizontally, the object follows a curved path before landing. A person jumping horizontally from a cliff to a lower cliff or into a river. The jumper moves forward while gravity pulls him downward. Time of flight. The time of flight is the time the object remains in the air. This is the time it takes the object to move from point A to point B. It depends only on the height, h. The initial speed of projection do not affect the time of flight. The object falls to the ground with the same time when thrown with different speed. The time of flight can be found using the equation of motion h is equal to ut plus half gt squared. Since vy is equal to 0, h is equal to half gt squared. Multiplying both sides by 2 to get a linear equation. 2h is equal to gt squared, making t the subject of the formula. T squared is equal to 2h over g. T is equal to 2h over g all square root. Range. From the equation, h is equal to ut plus half gt squared. The horizontal acceleration g is equal to 0. Velocity u is constant. The horizontal range r is given by r is equal to ut. This is the horizontal distance covered before the object hits the ground. The greater the initial horizontal speed or the height of the cliff, the greater the range. Resultant velocity v. The velocity of the projectile at any time has both horizontal and vertical components of the velocity. Horizontal component of velocity is equal to ux. Vertical component of velocity is equal to gt. The resultant velocity is given by v is equal to u square plus gt all square root. The angle theta between the direction of motion of the body and the horizontal is given by tan theta is equal to gt over ux. Example: a stone is projected horizontally from the top of a 50-meter high cliff with a velocity of 12 meters per second. Calculate a. the time it takes to reach the ground, b. the horizontal range of the stone, c. the vertical velocity of the stone just before hitting the ground, d. the resultant velocity of the stone and the angle it makes with the horizontal at the point of impact. Given height h is equal to 50 meters, horizontal velocity ux is equal to 12 meters per second, acceleration due to gravity g is equal to 10 meters per second square. The time to reach the ground t is equal to 2h over g all square root. Substituting in our values, t is equal to 2 times 50 over 9.8 all square root. T will be equal to 10.2 all square root. Square root of t is equal to 3.194 seconds. B. Horizontal range. Horizontal speed is constant, so range is equal to ut, which is equal to 12 times 3.194, approximately 38.33 meters. C. Vertical velocity just before impact after time t, Vy is equal to gt. Vy is equal to 9.8 times 3.194. Vy is equal to 31.305 meters per second. Resultant velocity v and angle with horizontal. Horizontal component vx is equal to ux, which is equal to 12 meters per second. Vertical component vy is approximately 31.305 meters per second. Resultant speed v is equal to vx squared plus vy squared, all square root. V is equal to 12 squared plus 31.305 squared, all square root. V is equal to 144 plus 980, all square root. V is equal to 1124, all square root. Final answer 33.53 meter per second. Angle below the horizontal measured from positive x axis downwards. Tan theta is equal to Vy over Vx. Tan theta is equal to 31.305 or divide by 12. Tan theta is equal to 2.609. Theta is equal to tan inverse of 2.609. Theta is equal to 69.03 degrees, approximately 69 degrees. I would love to hear from you. Share your thoughts with me. Bye. See you in the next class.